Hello again, everybody. Dirk the Engineer here, and today I'm going to talk about a program that I've been working on that really speeds up the process of woodworking with a CNC. Basically, I was getting sick of always having to go back to some sort of CAD to do a drawing, and then make some tool pathing, and then go to Mach 3 and run the program. It just takes too much time, and it was kind of inconvenient, and so I was just about ready to throw in the towel and get a decent table saw and a router station and all that kind of stuff, even though I had a CNC. And I thought, well, that's kind of foolish. Why don't I just try and see if I can make a program that is going to make the CNC a lot more easy to use before I go through the expense of trying to get the tools that would do the same kind of operations. And so that's kind of the impetus for this program. I chose to do it in Python with pyqt. You can get those tools through Python XY, and I'll show you where to get that in a minute. It is open source, and I am putting this up on GitHub as I develop it. Right now I've just got one, what I call a module or operation, woodworking operation working. And I'm quickly adding more. So with that in mind, let's just open up the program, and I'll talk a little bit about how you're supposed to set your machine up and what you need to do in order to use the program. So I just was able to create a little shortcut to the program, and basically what this is doing is launching Python in the background and bringing up the pyqt executable. So essentially, the way that I've organized this this program, you have your settings, which I'll go through here, and some tools that you will be able to use to make setting up your machine easier. And then I'll have a line of tabs along the top, and each tab will correspond to what I call a module in the program, but really what that is a woodworking operation. And then you'll have a set of basically user inputs that will define the operation and allow you to quickly produce your G-code. So right now, the one that I have working completely right now is the jointer. I'm very close to getting the straight line rip working, and other modules that or other operations that I want to do are profiling, and I want to do basically every kind of dovetail that you would want to do or could do with a dovetail jig, including the Incra style dovetailing. That will take a little bit of time because it's a little bit more involved, but I thought I would just get my feet wet doing this, and it actually works and produces usable G-code that functions as you'd expect. Just a quick note about liability. I in no way accept any kind of liability for machine or personal injury, machine damage or personal injury. It is completely up to you, the end user, to inspect the G-code that comes out of this program before you use it, and if you use the program, you're accepting that as a true statement. If you don't accept that as a true statement or agree to it, then you have no right to use the program. I'm not gonna accept liability for that in any way. It's up to you to know the program, to learn it, to know how to set it up, and to use it safely on your machine. So with that out of the way, I just wanted to now talk about how you should set up your router to use with the program here. So let's just imagine that this white space here, kind of drawn out by this box, is like your router bed. For me, I have a 4-foot by 8-foot machine, so my gantry moves up and down this direction, and this my router head car runs up and down this direction. For me, I call this direction X and this direction Y. Now you notice that that is what they call a right-handed coordinate system. I'm not going to explain what that means, but you need to know that. Maybe you can look it up on Wikipedia. But basically that means that if you're looking at an XY plot, X would go to the right and Y would go up. Okay. Now X can run this direction and Y can run that direction, or X could run this direction or Y could run that direction. But if Y runs this direction and X runs that direction, that's called a left-handed coordinate system. And you can look up and find out what the difference is and how to set that up to make sure that you have a right-handed coordinate system. Okay, so let's just take a look at some of these settings then. In the machine, this actually kind of defines the necessary parameters to tell the program where are good bounds for it to play in. Okay, so on my machine, I have a maximum travel of 99 inches in, is that right? I think it's 97 inches actually, and 98 actually, and 51 in the Y, with a Z travel of 6 inches. Okay, so that's where you put these absolute limits in. And my spindle speed maximum is 24,000 RPM. Okay, right now everything should be defined in inches because that's what I natively work in. But let's see here. I think if you work in millimeters and you define all your units in millimeters, you just have to change something in the preamble to make sure that the machine knows that it's supposed to be looking at millimeters instead of inches. So I haven't tested that out, but I know it works in inches. So, all right. So now the actual bed dimensions that I have, I can do 97 by 49. So actually, I think it was 99 because I think I have 2 inches extra travel in each direction. The bed offset, which is the distance from the home switch to the bed origin for me, is 0.3121 inches, and the similar Y offset from the Y limit switch is 0.8574. Okay, so those are the necessary dimensions to make sure that the machine or the program will know where your bed is and how far it can move to play in the sandbox without going out. Okay, the next thing that you have to do, I have a grid, and I will be heavily using the grid in my woodworking system. Basically, if this was my bed, what I've set up is in my MDF spoil board, I've drilled a series of 1/2-inch holes in an array. Basically, they're on 1.5 inch centers that go in both directions. So I think I have a little under 2,000 holes in my bed, but it doesn't take long for the machine to drill and bore out and precisely locate all those holes, so that you can set up the same thing. I highly recommend that because it allows you to have a lot of freedom in where you locate your work as you're going. So this is the way that I have defined my grid. So the grid offset is the distance from the table origin, not the home limit switch, to the first hole closest to the origin. Again, the grid spacing is 1.5 inches. The Y offset is, I think it's 2 inches actually. I have to go back and measure that. Again, I'm in the testing phase. I don't have this all quite set up yet. And then again, it's 1.5. Okay, and then my pin diameter is slightly larger than 1/2 inch. And I have 61 rows in the X direction and 30 rows in the Y direction. So that defines the grid. So my first hole is 3 inches from this side and 2 inches from this side, and I have 60 holes that go in this direction, and what was it, 31 in the other direction? No, 61 in this direction and 30 in this direction. So that will define that grid. And once I know that, I can then use a grid coordinate system to locate my pieces of work. And I start at 0, 0, and so then it would be 1, 0, 2, 0, 3, 0. So X going off this direction and Y. So it would be, if it was at 0, 0, then it would be 0, 1, 0, 2, 0, 3, so far up this direction. So that's kind of how the setup of the table and grid works in relationship to these settings. The other thing that you need to know is usually there are some things that are always added to the start of the G-code to define certain parameters, and this is what it works out to be for mine. I don't remember which one of these is, but one of them says use inch units, and I think if you use metric units, you would change that in this preamble somewhere, and then all of the numbers that are input in here would then be metric, and I think that will all work out. The other thing is there's a postamble, some things that should be added to the end of every program to make sure everything is shut down properly, and that is put in there. Then the other thing is you want to choose where your default G-code folder is. And in this case, I'm just doing tests on this machine, so I have it in CNC Woodworking GCode, and that's where we'll keep that. And I'll just go ahead and open that up and make sure that that's cleared out for right now for this test. CNC Woodworking. So you can see I've done some other tests, so I'll just delete these files. Okay, so now we can talk about the jointer. Okay, so essentially the way that I've set this up to work is that you take your workpiece, your board that you want to create a straight line joint on, and you lay it up against the edge of the bed, either this in the X or the Y direction. That's what this is. So primarily I like to work in my X direction. I find that that's easiest because I can get to the points where I need to hold down the work the easiest, and I don't have to lean so far. And I don't really ever use it in this direction. I'll try it and see once it works. I mean, it does produce the right G-code. I've tested it, so I just don't use it personally that much, but others might. Okay, so over travel is basically how far do you want to make it start, because it's going to put let's say that your board starts here and ends here, but your table goes from here all the way to here. So over travel would say, okay, I'm going to go a half an inch in this direction before I put the bit down, so a half an inch past my work, and then go all the way a half an inch past this direction. That way, you're not coming down on top of your work in any spot. And you want to set that to a comfortable margin so that you know where you're going, okay? Then the safe Z height is the height above the bed that the bit should raise to, so that you know that it's not going to hit anything. So basically it should have complete freedom of movement over every part of your table at that height, so that it doesn't have to worry about it. That way it can wrap it at that height. The Z-axis offset is, sometimes if you're at the very edge of your table, you might want to set that to minus 0.05 or something like that, so that it actually goes down past the table a little bit, so that you're not. It gets the full width of the side of the cutter, so that it produces a very clean joint. But if you're doing it and you don't have your origin isn't right at the edge of where your your bed is, you might want to keep that at 0 so it doesn't plug into your bed at all. Okay, so now let's talk about cut passes and final passes. I've worked with some pretty rough materials in my shop, and rough sawn materials, and when they dry, sometimes they have a really big bow in them, big enough that I'm not just shaving a little bit off. And so these cut passes are designed to progressively cut down along that cut line into the wood, so that it can basically slice that curve off before it does the final pass. Okay, so if your board is nice and straight, you want to leave this at 0 and just deal with final passes and just overhang your board by just a small amount. But if it's not, then you're going to want to use some cut passes. And basically, you're going to want to look at your material thickness and then kind of think about how much of a how deep you want your bit to be cutting on each pass. So for instance, if you want to make a 1/4 inch pass every time with a 3/4 inch thick board, you'd want to set it to 3. Okay, so basically it's going to take this and divide by this number to get your thickness, right? So it's going to do that number of passes. Okay, so this cut offset is kind of important, and the reason that I have it negative, so since I have the x-axis selected, I have it set to negative because I want it to move in the negative direction in y to give me some allowance before I do my final cut. So I'm giving it 50 thousandths cut offset in the minus y direction to cut that off before I go to my final pass. Okay. The cut pass spindle speed is defined here, and the feed rate is fairly obvious if you know how to do any kind of G-code creation. Alright, so then in the number of final passes is different than cut passes. The final passes is a full width cut or full depth cut. And the reason I do this is because I find that sometimes the first pass doesn't produce the most precise straightest line because of tool pressure and compliance in the system. And not only that, is that sometimes my feed rate is a little too fast, and I don't get the smoothest edge cutting that off. So I want to do actually multiple passes at full depth to shave that off. So here, I've defined this final offset as 0, which is going to then come up relative to this position by 50 thousandths and then start making these passes. And I can do more passes than that. And the more you do, the straighter and smoother theoretically it should be when you do that. But I usually find about 2 is enough with my system. And again, you're defining spindle speed and feed rate for that operation. Now, in terms of the material, you're assuming that the length dimension is along the axis that you select. So if I select x-axis, this length measurement is along this direction. If I select y, the length would be along this direction. Okay, so material width then is in the other direction. So for the x-axis, the material width is this direction, and the thickness is the height off the bed. Now the distance from the origin, let's say that this is where my origin is defined, I said that it's 1 inch along that axis. Okay, so basically what this is going to do when it makes this cut pass, since I have the over travel defined as a 1/2 inch, it's going to go from 11.5 to a half, right? Because I have 1 inch to the edge of my board. My board is 10 inches long, and then I need to start a 1/2 inch there and then end a 1/2 inch in the other direction. Okay. And then this just tells you tool properties, diameter, cutter length, and stick out. So it gets some approximate values to know whether or not you're going to see some over travel in the Z direction. Okay. Eventually, I will have a tool database. Right now, this is non-functional. It just doesn't do anything. And I'm going to link this to a feeds and speeds calculator here. Again, that's not functional. Neither is the load tool at this point. But like for instance, if you wanted to look up what your feeds and speeds should be for these operations, I like to use gWizard, and so I will make a directory to the executable so that when you hit the feeds and speeds calc, it will bring up whatever calculator you have selected. Just a convenience item. So once everything is defined, you can go ahead and set generate G-code. Now what this is going to ask you first is if you want to include setup G-code. And I recommend doing this at least for the first few times that you're trying to set up your bed. And what this is going to do is position the tool at the start of the tool path for the final pass. So it's going to, in this case, it's going to put the tool basically half the tool diameter down at 11.5 inches along this axis, and it should be at the z-axis offset, I believe. So it's going to put it there. That way you can check to make sure that you're going to the right spot before you go ahead and commit to doing the operation. So I'm going to click yes, and I'm just going to give it a name, test, and go ahead. So now that that's set, I have this open, and we can look at the setup. Okay, so here's the end of the preamble. So it's going to go to our safe Z height, and it's going to move to. Okay, now the reason that this is different is because it's actually it's not 11.5. Okay, like I was talking about, that 11.5 was in reference to the table origin, not the machine origin. The machine origin is actually somewhere down over here because that's where my limit switches are. Okay, and so basically what I've set this up to do is to go so that I never have to worry about trying to zero or find this edge or anything else on the table. I'm just calculating everything from the machine origin or right off of the home limit switches, and so that's why that number is a little different. So 11.8 and a y of 0.67, which is where it's supposed to be. Okay, and then it moves down to that z, and then it basically is done. So it just moves it to the position where you think it should go, and that way you can check to make sure that you're not doing something in gross error before you actually cut the piece of wood. So you could load that up and run it. All right. Then the other thing is actually the G-code that you would run, and of course here you go. In my machine, this is actually turning it on. So you have to have it in a safe location before you turn it on. That's another requirement, I should say. So it turns it on, and I've had issues with Mach at some points. It doesn't start the spindle, so I always put a pause statement for 5 seconds before it goes. That way it gives me enough time to register in my mind that the spindle is actually going and doing what it should be doing before it starts moving anything, and I can kill the process before it starts there. It doesn't happen very often, but when it does happen, it can break a bit if you run your machine too hard. Really easy. So anyway, so it goes to safe Z, and here we go. We're starting going to that cutoff. It's lowering it down about 1/4 of an inch into the material, and then running it to the other end. So you can see X is now there. Then it's giving you feed and speed again, which I'm not sure that it needs to do that, but Put another pause in there. I'll have to take a look at that. I'm not sure why it's doing that. But then it picks the head up again and does goes back and then goes down farther again back to the start the end position. Seems like I must have something out of order since the last time I checked this, because it shouldn't be putting all these statements in right here. So it's repeating that, and then you get to the final depth, and then it switches to the feed and speed of the final pass, and again it goes to the 11.5 and down to the maximum Z and maximum plunge depth, and then does the travel to 0, again up and back and down and across, and then turns the spindle off, goes up to the safe Z height, and traverses down to the end of my table so that it's out of the way. And again at Z equals 3. So, and then it does the post-amble and shuts the machine down properly. So it actually does work, with the exception that I need to check to make sure that these statements are being written correctly. It only needs to write that once at the head of the cut. So it does the right number of cuts, the right number of passes, and moves itself out of the way. So it does work, and I'd encourage you guys to start to use this as it gets developed here, and help me find bugs and stuff like that too. I will go over the straight line rip stuff at another time when I actually have the G-code stuff finished up, and have the GUI a little bit more. I think eventually I'm going to split this window in two, and I'm going to try and do like a bed view to show you where you're defining your cuts and stuff like that. But that's a lower priority. You should, in order to use this tool, you really should know the basics of G-code and how to interpret what's going on, so you're not surprised about where your machine moves. And at this point, I would really check that just about every time you use it until you get really comfortable with it, because otherwise it's easy to crash your machine, and definitely operate your machine safely. So I'll just show you where to get the G-code here. I have it set up on GitHub, so if you're not familiar with that, it's www.github.com. Alright, and then once you get there, you can find where I am. Just do user dirk the eng in the search box, and that will pull up all of my various gits on the GitHub, and it's this last one. And then to download it, you can just download the zip, and that will basically contain the entire working folder that I currently have on my machine as I update and push it to the GitHub. In order to use this, you will have to install Python, and I recommend that you use Python XY. So if you just go into Google and do Python XY, alright, then you can go to downloads and pick one of these. I use 2.7.5.2, I believe is what I currently use. They do have, I think they're going to be moving to Python 3 at some point here. In fact, I think they have a dev branch here for Python 3 somewhere. but I don't use that yet because not many of the modules are compatible with Python 3 yet. So everything in this project will be coded on 2.7. And I don't think I need anything else at this point. It's pretty straightforward. So yeah, so download this and then go to GitHub and download this. And if we want to start branching, anybody want to help with development or do anything on their own, just let me know and we'll set up some branches and stuff like that. So yeah, hope you enjoy using the program, and I will hopefully hear from you back. Write comments on the YouTube, and or email me at dirktheeng@gmail.com with questions, comments, or any kind of bug reports, or you can submit them through GitHub as well. Yeah, I'll get them. So, all right. Thanks very much, and I'll talk to you guys later.